In this illustration, we are given a thin bioconvex lens of refractive index 3/2 is placed on a horizontal plane mirror as shown in the figure. You can observe this is a horizontal plane mirror, and here biconvex lens of refractive index 3/2 is placed. Okay. In the next line, it is given the space between the lens and mirror is filled with a liquid of refractive index 4/3. That means this space is filled with the liquid of refractive index 4/3. In the next part of the question, it is given, it is found when a point object is placed 15 centimeter above the lens on its principal axis, the object coincide with own image. That means object and image position is coinciding at a distance 15 centimeter at the top of the lens. In the next part of the question says, on repeating with another liquid, the object and image coincide at a distance 25 centimeter from the lens. That means if we replace previous liquid with the liquid of unknown refractive index, the object and image both coincide at a distance 25 centimeter from the lens, and here we need to calculate the refractive index of the liquid. This is the question, right? So let us make the diagram to the next page. This is the situation, and in the first part of the question, it is given the space between the lens and mirror is filled with a liquid of refractive index 4/3. That means this space is filled with a liquid of refractive index 4/3. Top of the lens there is air, and refractive index of air is 1, and lens is having the refractive index 3/2, and this liquid is having the refractive index 4/3. And at a distance 15 centimeter from this lens on the principal axis, we have placed this object, and this distance is 15 centimeter. At this distance, the object and image both are coinciding, right? This situation will be possible only when the light retraces its path. That means after passing through the liquid, light ray incident on the mirror normally. If light ray incident on the mirror normally, that means after passing through this system or after passing through the liquid rays are becoming parallel with the principal axis. That means final image is forming at infinity from this system. And in this case, you can observe this thin lens is exposed to two refractive index, top refractive index 1 and bottom refractive index 4/3. That means in this particular case, the thin lens formula is not applicable. That means we need to use this formula which we have learned now, this one, right? Mu2 divided by V minus mu1 divided by U equal to mu minus mu1 divided by R1 plus mu2 minus mu divided by R2. In this case, in the first case, you can observe here, we need to, in this formula, we need to put the value of radius of curvature of the first surface and second surface. But in the question, we are not given the radius of curvature, but we are given the refractive index at top and bottom. We are given U value, we are given V value. That means if we substitute the value of mu1, mu2, mu, U and V, we can find the value of R1 and R2. And given lens is the biconvex, that means R1 is equal to R2. So here let us assign the positive direction as downward direction. That means U value is equal to minus 15 centimeter, and rays are becoming parallel to the principal axis because they are incidenting normal to the mirror given. That means V is equal to infinite. And here mu1 is equal to 1, mu equal to 3/2 and mu2 is equal to 4/3, right? So let us substitute these values in this formula. So let us substitute, this is the surface 1, let us assume the radius of curvature is R, and this surface 2 is also having radius of curvature R, right? As we are assuming downward direction as positive, that means radius of curvature corresponding to the first surface should be substituted with the positive sign, because center of curvature will be at the bottom side below the curved surface, you can say, and the center of curvature of the second surface will be on the top. That means radius of curvature for the second surface should be negative. So this for the first surface r should be positive and second surface this r should be negative. So let us substitute the values. Now if we solve this, this should be equal to 1 by 15, right, because this divided by infinite equal to 0, and this should be equal to this one if you calculate, and after calculating we will get the value of r equal to 10 centimeter. That means we got the value of the radius of curvature of the top and bottom surface. Both will be equal because it is a biconvex lens, right. Now let us consider the second situation. In the second situation, we replace the liquid of unknown refractive index. Now in this particular case, the image and object coinciding at a distance 25 centimeter. That means the situation is same, because we got the value of r1 and r2, that is r equal to 10 centimeter and u equal to minus 15 centimeter in this case, and these values are same, and v is again infinite, and here we are having one unknown, that is the refractive index, that is mu2 value. So let us make the situation, this is the second situation, this is the liquid of unknown refractive index, right, this is at a 25 centimeter and this u should be equal to negative because we have assuming downward direction is positive. So this is minus 25, mu1 equal to 1, mu2 is unknown, mu equal to 3 by 2 and v equal to infinite. So let us substitute this value. This is surface 1. Now we know this value 10 centimeter and we know this is also 10 centimeter. So let us substitute. Now if we solve this, this will be 1 by 25, right? This will be 1 by 2 multiplied by 10, 1 by 20, and this should be equal to minus mu liquid divided by 10 plus 3 divided by 20. And if we solve, we will get the mu liquid equal to 8 by 5. That means the refractive index of the liquid filled at this space should be equal to 8 by 5. Now let us solve the same problem by method number 2. If you observe this situation, you can replace this system, that the system of this bioconvex lens and this liquid, as a combination of the two lenses. This is a lens, bioconvex lens, and you can assume this lens below this bioconvex lens between the lens and mirror. This is a plano-concave lens of refractive index 4 by 3. And here you can observe these two lenses are placed side by side. Here we can define the effective focal length of this combination, that is capital 1 upon capital F equal to 1 upon F1 plus 1 upon F2. The focal length of the bioconvex lens or this plano-concave lens can be found out using the lens maker formula. So let us calculate the focal length of this lens, and here the radius of curvature is unknown. So here we assume R1 equal to R2 equal to capital R, right? So for the first lens, we can write first surface radius of curvature as positive because center of curvature will be at the bottom of this surface, right, in the direction of the ray traveling if we measure this length. So R1 is equal to positive and R2 should be negative for this surface because center of curvature will be at this point, top of the lens. That is, for measuring we need to move in the opposite direction of the positive. Positive direction is from bottom, top to bottom, right? So here we can write 1 upon F1 equal to 3 by 2 minus 1, 1 upon R minus 1 upon minus R. After solving, we can write this is equal to 1 upon capital R. This is the focal length of the first lens. Now let us consider the focal length of this plano-concave lens. The radius of curvature for the first surface is R and this is negative. Radius of curvature for the second surface is infinite and refractive index is 4 by 3. So here we can write 1 upon F2 equal to 4 by 3 minus 1, 1 divided by minus R minus 1 upon infinite. And this after calculation we will have minus 1 divided by 3R, right? Now we know the image and object both are coinciding. That means rays after passing through this system are incidenting on the mirror normally. That means after passing through the combination of the lens, the rays are becoming parallel to the principal axis. That means this 15 centimeter should be the equivalent focal length of the system. That means F should be equal to 15 centimeter. So in place of the capital F, we should substitute 15 centimeter, right? And in place of 1 upon F1, 1 upon R, and in place of 1 upon F2, minus 1 divided by 3R. From this relation, we can find the value of the radius of curvature. This is equal to R equal to 10 centimeter. So we got the radius of curvature of top and bottom surface. Now let us repeat the same experiment with another liquid. This is the liquid of unknown refractive index. The steps are same as we have done in the previous case, but one thing is unknown, that is only the refractive index of the liquid. That means here also we can find the combined focal length, that is 1 upon capital F equal to 1 upon F1 plus 1 upon F2. Now we have the radius of curvature value. So here we can get the 1 upon F1 equal to 3 by 2 minus 1, 1 by 10 minus 1 divided by minus 10. So this after calculation is equal to 1 by 10 centimeter to the power minus 1 in centimeter we are calculating. And for the second focal length, that means plano-concave lens of refractive index mu liquid, we can write 1 upon F2 equal to mu liquid minus 1 and in bracket of minus 1 divided by 10 and minus 1 divided by infinite. And this after calculation we can write minus mu liquid minus 1 divided by 10, right? And here object and image both are coinciding. That means rays after passing through the system become parallel with the principal axis. That means the focal length of the combined system is equal to 25 centimeter in this case. So we can substitute this value. From this relation we can find the value of mu liquid because this is only a known quantity. So this after calculation is equal to 8 by 5. You can observe the same value we are finding as we have done in the previous case. Now let us solve the same problem by another method. Method number 3. If you observe this system, this is a bioconvex lens and we can assume this is a plano-concave lens, and below the plano-concave lens there is a plane mirror. And here we can assume this plane mirror is not placed, but we have polished the bottom surface of the plano-concave lens. Now this case will be a case of the polished lens, and a polished lens act as a mirror. So this system will act as a single mirror now, right? And here we can observe the ray will incident on this equivalent mirror. It will interact with this lens twice, interact with this lens again twice, and interact with this surface once. That means the equivalent power of this system can be written as 2PL1, 2PL2 plus PM, right? This is the equivalent power of the system. For calculating power, we need to know the focal length in meter, because power of the lens is equal to 1 upon focal length and power of the mirror equal to minus 1 upon focal length. So let us calculate the focal length of this lens. This should be equal to 3 by 2 minus 1. We are using the lens maker formula. So we can write 3 by 2 minus 1, 1 upon R minus 1 upon minus R. Okay. After solving, we can write this equal to 1 by R. Now come to this lens. That's the plano-concave lens, 4 by 3 minus 1. We are again using the lens maker formula, and radius of curvature for this surface will be negative. So we can write this expression because this surface, bottom surface, having the infinite radius of curvature because it is a plane surface. So this is equal to minus 1 divided by 3R. And this is a plane surface polished. That means the focal length of this plane surface should be infinite. Okay. Now we can substitute the focal length in this relation to get the equivalent power. This one, right? Now if we solve, this value is equal to 4 divided by 3R. Now this is the power of the equivalent mirror. Now we can write the focal length of the equivalent mirror form is equal to minus 1 upon equivalent power. This is the equivalent focal length equal to minus 1 upon equivalent power, right? And this is equal to minus 3R divided by 4. Now it is given the object and image both are coinciding at the same position. That means this point should be the center of curvature of this mirror system. That means this distance should be equal to 15 centimeter distance should be equal to radius of curvature of the equivalent mirror. Radius of curvature means twice the focal length. That means this 15 centimeter should be equal to twice the focal length. So here we can write twice the focal length of the mirror equal to 15 centimeter, and we have this expression for the focal length. So let us substitute the magnitude, because we are interested to calculate the radius of curvature magnitude. So this should be the radius of curvature. After solving, we'll get r equal to 10 centimeter. So we got the first part. Second case will be the same as the first case, only the difference will be mu liquid is unknown. So let us move to the second part. In the similar way, we can write the equivalent power, right? This is 2PL1 plus 2PL2 plus PM, as we done in the previous case. Okay, now we know the focal length 10 centimeter, but we know for calculating power we need to substitute the magnitude of the focal length in meter. So this is 0.1 meter, this is 0.1 meter. So let us find the focal length in meter. This is 10 meter to the power minus 1, right? Now come to the calculation of the focal length of this part, that's the plano concave lens. This is equal to 1 upon f2, and here as a known is mu liquid. So we can write like this. Okay, so we can get the value minus 10 mu liquid minus 1. Now we can substitute this value in this equation to get the equivalent power, right? So here the equivalent power after calculation, this is equal to 22 minus mu liquid. Now we can get the focal length of the equivalent mirror form, that is equal to minus 1 divided by power, right? This is equal to minus 1 divided by 22 minus mu liquid, and this will be in meter. Let us convert this value in the centimeter by multiplying this value by 100. So this is equal to 5 divided by 2 mu liquid. This is the focal length of this system. And we know object and image are coinciding at the same position. That means this 25 centimeter should be the radius of curvature. And we know radius of curvature is twice the focal length. That means twice of this value, magnitude of this value will give the 25 centimeter. So let us substitute this value in this expression, right? And if we solve this value, this is equal to mu liquid is equal to 8 by 5. And this is another method, method number 3. This is the method number 3. Okay.